Hey all, we're gonna do, on this Tuesday where we're not meeting live. I'll just kind of post this video of this next handout, like in your binder, the solving proportions classwork. So hopefully a fairly quick video, just kind of running through this handout, and then you can turn it in. You can turn in a pic of your work. Okay, I'll have an assignment for that posted, today, which is pretty much how you're seeing this video through the assignment I will post later on today. But this goes, very much hand in hand with section 3.1 and 3.2 and 3.3. This hasn't got an actual section, label. It's not like this is section 3.4 or anything. It's just kind of like this sort of random but not random, little topic tossed in there that, like I said, goes along with 3.1, 3.2, and 3.3 pretty good. Like, just look at 1, 2, and 3 here. These are equations that we want to solve for x. But something of note is that they are proportions. Proportions are what you can call an equation where there is a fraction equal to a fraction, or two equal ratios or two equal rates or something. Basically, two equal fractions. Even number 3 is just like one fraction equal to another one fraction. And maybe you recall that the classic way to approach solving a proportion for x is to cross multiply. Cross multiply. Like do the 6 times the 9 and the 27 times the x. That makes sense with a fraction equal to a fraction. Because again, like when I do 27 times x, what's sort of actually happening is we're just multiplying both sides by 27. Well, first of all, let me kind of write this out. So I'll write the 27x first, and then the 6 times 9, So that's what you get when you cross multiply. 27 times x, and then the equal sign, and then 6 times 9 on the other side of the equal sign. Just like over here, cross multiplying, you'll end up with 10x equals whatever 7 times 25 is. So you're multiplying diagonally, and the equal sign goes in the middle. But this obviously makes sense because when you do 27 times x, and just write this as a 27x, in a way you're just multiplying 27 to both sides. You're multiplying the 27 to the other side with the x, but at the same time you're multiplying both sides by 9. Like you're multiplying 9 to the other side to kind of multiply to the 6. So cross multiplying is just, again, it's not difficult to understand like why that's allowed, because again, you could break this up like this one. You could break this up into 2 steps and say, well, let's just multiply 7 to both sides, and it'll be over here now with the 25. And then we'll multiply 10 to both sides, and it'll now be over here with the x. You know what I mean? But cross multiplying is a very classic little shortcut, I guess, if for lack of a better word. But now that I've cross multiplied, okay, I can, do 27x equals, I believe, is 54. And then you can just like continue solving for x the way you would always solve for x and get x by itself. You can divide both sides by 27, which will, cancel out that 27 and leave x all by itself. And I believe that's just a nice answer of 2. Likewise over here, to finish the actual cross multiplying, let's actually do 7 times 25. Oh boy, let's see, that should be 175, right? I'm pretty sure pretty sure that's going to be 175. Check your calculators if you think I might be wrong. I mean, maybe I am. But I'm just going to go with 175. And then we would then, of course, want to get x all by itself. And then that should be 17.5 as a final answer for x. Okay, over here, this looks very intimidating, right, at first. Look at all this craziness, you know? But if you happen to notice that is just one fraction equal to one fraction, you can cross multiply. Now, you just got to keep in mind that when you do 3 times, like this denominator times this numerator as a whole, it's just going to be like 3 times that whole thing. Maybe I can sacrifice, I hope I have enough room here, but I'll write it out as a baby step. You know, that 2x minus 6 would just, you would need to think of that as being like in parentheses. The entire quantity of 2x minus 6. Like you're not just multiplying 3 times the 2x, you're multiplying 3 by this whole thing, which is, all that means is it's going to require some distributing, you know, the distributive property. Likewise, when you do this other multiplying, you know, like this 4 times that entire numerator of x plus 1, you're just going to need to have it in parentheses, you know. And so when you distribute, you get 6x minus 18, I do believe. And then when you distribute over here, you get 4x plus 4. And now after you've cross-multiplied, now you just continue on your way of, you know, solving for x. The first thing we have to do is get the x's only on one side, the terms with x. So I would subtract 4x. So now it's no longer on the right side. Now it's over here. And 6x minus 4x is 2x. And then and then over here we still have a positive 4. And then once you get the x's only on one side, now it's time to get that x all by itself, you know. So first thing we would do is get that out of there so that we can have 2x alone over here, and over here it'd be 22. And then when we divide both sides by 2 to finish getting x all by itself, you end up with x equals 11. So that's how cross-multiplying works, even on tricky problems like number 3. Moving on, okay? Number 4. Number 4 and 5, we have like a word problem. Oh well. Let's see how this works. A 3-foot-tall child casts a 60-inch shadow. Nearby, a tree casts an 8-foot shadow. How tall is the tree? So, I mean, I don't think this is going to take too long for me to explain. 3-foot-tall child casts a 60-inch shadow. I know that this is like not to scale. Oh my goodness. You know, because actually 3 feet is longer than whatever, you know what I mean? Sorry. Actually, is it? I take that back. I am an idiot. Why did I? 3 feet is 36 inches. So I was kind of... I'm really glad I caught myself there. I wonder why I was able to make that mistake. Just because like 3 is smaller than 60? But no, 3 feet is actually only 36 inches. But whatever. That's not the point right now. The point is this, and then when you talk about like this tree, you know, that makes an 8-foot shadow. Jeez. 8 feet. It's almost like we want that to be in inches, you know. Oh man, number 4, this gets extra complicated because of like how we're using inches and feet almost like willy-nilly, you know. This shadow is in inches. This shadow is in feet, you know. Just to be safe, let's make all of this in inches. Like I'm pretty sure it would work if we only made like 8 feet into inches, you know. But let's turn this all into inches. So 3 feet, like I said already, is 36 inches. And then 8 feet, what's 8 times 12? Because there's 12 inches in every foot. So then 8 times 12, 8 whole feet would be 96 inches. So this is what we want to know. Okay, that's what we want to know. Now look, again, I didn't want this to take too long, but the bottom line is what we have here is similar triangles, but that's not what's really important for me to emphasize. What really matters is this kind of scenario with like shadows, when you have like, someone that's a certain height or something that's a certain height casts a shadow of a certain length. The bottom line is you can write a proportion for this. That's the bottom line. The full explanation involves how these are similar triangles and there's like similar ratios and blah, 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 blah. But we can write a proportion. So 36 tall child casts a 60-inch shadow. You could also make a fraction with this unknown tree height and the 96-inch shadow. So the bottom line is you can make a proportion. Okay? And by the way, there's other forms of this proportion you could have written. Like you could have made one fraction the heights of the objects or people, Like you could have made one fraction, here's the child, here's the tree, and that's going to match up with the child's shadow and the tree's shadow. So this would have been another correct proportion you could have written based on this word problem. But let's just go with this one, child's height, child's shadow. Tree's height, tree's shadow. Like everything's in its place. So now we just cross multiply and we get 60x equals, I think I will grab my calculator for this. Let's see, 36 times 96. Oh boy. 3,456. And then the last thing we got to do is divide by 60. So on my calculator, I might as well just hit divided by 60. Oopsies. Oh no, oh no, oh no. 57.6. So the tree is only 57.6 inches. That's technically 57 and a half. No. Oh my gosh. What the heck, man? Never mind. If that was, never mind. Oh my goodness, I almost made another mistake. No, just 57.6 inches. Okay, which is not the same as, like what flashed through my head just now is that like 6 inches is half of a foot. But this isn't 6 inches. It's 0.6 of an inch. So, never mind. Okay, number 5, likewise, because when you have like these comparative like scaled ratios, you can write a proportion. So the length of a college campus in a blueprint is 15 inches. The actual length is 2 miles. So that can be one fraction. 15 inches in the picture is 2 miles in real life. The width of the blueprint is 12 inches. What will the width of the, so we can make another, but 12 inches in the drawing goes with what in real life? So picture, real life, they all go together. Again, you could have made like another proportion where you had like, 15 over 12 equals 2 over x, whatever. But we cross multiply because it's a proportion. We have a fraction equal to a fraction. And so we have 15x equals 2 times 12 is 24. And then when we divide, now we got to get x by itself. To do that, we divide both sides by, now again, we could go with a decimal. We could just reduce this fraction, Let's reduce it at first. I think is 3 the biggest thing. So like if you take out a 3, you have like 8/5. That's going to be a nice decimal. 8 divided by 5 is 1.6. So the actual width of this campus is 1.6 miles, because this was in miles. Miles, inches. So 1.6 miles. Moving on to percent. Okay, now, percent you can actually also make into a proportion, because remember, 68% is literally a fraction of 68 over 100. Okay, so we want to think about what the question's asking. What is 68% of 140? So 68 out of 100 would be the same as what number out of 140? You get it? What number out of 140 would be basically the same as 68 out of 100, and therefore it's 68%. So here's a proportion you can write. Over here, number 7. I'll even wait to solve this because there's a little bit more to the story. Number 7, 84 is what percent of 120? Now again, you have to read that maybe a couple times to wrap your brain around it, because 84 is what percent of 120? So how could we write that as a proportion, right? It's kind of like saying 84 out of 120. What percent is that? The fraction 84 out of 120 would be the same as what number out of 100? Get it? What percent? What percent? What percent? Number out of 100 is unknown would equal 84 out of 120. So there's a proportion that you could now cross multiply and solve for x. Number 8, 12 is 24% of what number? Okay, so 24 is the percent. So 24 out of 100 would equal what? 12. 12 is 24% of what number? In this situation, it's like 12 is the part, and we don't know the whole. 12 is like the 24%, but out of what? So it's like 12 out of what would be the equivalent to 24 out of 100. So what number would make this fraction equal to basically 24%, 24 out of 100? So again, you can now cross multiply and solve for x. But in this cross multiplying, you do certain math, you do this multiplying, and then you essentially end up dividing by 100. Over here, you do this multiplying, and then you essentially end up dividing by 120. You know what I mean? Maybe I won't get into the shortcut right now. Just to kind of make, just to at least give you something, so you're not completely confused of what I might be talking about. The shortcut over here in number 6 is to just turn 68% into a decimal and then multiply it by 140. So instead of doing all the steps of this cross multiplying, if you know the shortcut to do this percent question, it's really just this, do 0.68 times 140. It's you end up doing this math anyway, when you cross multiply, but you can still think of this as a shortcut, at least a little bit of a shortcut. So that's what I was talking about. I'm not going to really get into what the shortcut is for number 7 and number 8. Just because you can do the cross multiplying, and because you might already know what shortcut I'm talking about, I'm not going to muddy the water right now too much. Yeah, you could just cross multiply. Which I'll leave that to you to finish up. Okay, cross multiplying. Number 9, what is the percent decrease if your weight drops from 240 to 210? Okay, and then number 10 is fairly similar. So 9 and 10, we're talking about percent change. It's taking it to a little bit of another level, a little bit of level of difficulty higher. Talking about, not just what is 68% of 140 or 84 out of 120 is what percent. Now we're talking about a percent change. Well, it's actually not that complicated. So here we go. Let me teach you. So we're going from 240 to 210. We've lost 30 pounds. Okay? So when we go from 240 to 210, the first thing you need to do is think about like how many pounds you actually lost, you know, and then like what percent decrease. So we lost 30 pounds, but what percentage did we lose? Okay, well, that all depends on what you started with. That's huge. Okay, like let me say that again. It all depends on what you started with. What did you start with? What did you lose? You know, because think about this. If you have like, you know, if you're 240 pounds and you lose half your weight, you've lost 50% of your weight. That was a 50% drop when you lose half of it, you know, so that's like 120 pounds. You know, if you lose 120 pounds and you're this heavy, that's a 50% drop. But like if you weigh 500 pounds, you know, and you lose 120 pounds, that's not 50%. That's less percent. Just like 30 pounds, you know, 30 pounds is not 120 pounds. So losing 30 pounds, this is not going to be a 50% drop, because a 50% drop would have been 120 pounds. But here, all we do is this. We do, okay, what about when we compare 30 to 240? What percent is that? You know, so there's the proportion that you would set up. 30 compared with 240, what you started with and what you lost. What similar fraction would that be? You know, like what number out of 100 would match this fraction? And once again, I will leave the cross multiplying to you to finish. Number 10, very, very similar. What is the percent increase if your salary goes from 40,000 to 41,000, you know, 600? See, again, what you actually increased was 1,600. Like that was your actual increase. Now, if your starting salary was only like a couple thousand, you know, a couple thousand or something, then this increase is massive when it comes to percent. You know what I mean? But if you have like 40,000, this is only going to represent, you know, a certain like smaller percent. Again, I want to like hammer this point in. So let me come up with maybe another maybe easier example off the top of my head. So let's see. Like imagine you're making $40,000 a year and you get an increase of 20,000. Like holy crap. Percentage wise, considering you only started with 40,000 and you're getting a raise of 20,000, that's a 50% raise. Okay? Now, let's say you're making 40,000 and you get a raise of 40,000, you know, like holy, that's doubling your salary. You know, so for someone that's only making 40,000 to begin with, you just made a 100% increase. Like when you literally double it, you know? But now imagine you're making like $500,000 a year. You're already making $500,000 a year and you get a $20,000 raise. Percent-wise, that's not the same thing. So whatever your raise is, in this case, it's only like $1,600, which is nothing to sneeze at, okay? That's why it matters what you started with. So that's why you do like 1,600 over the 40,000, the number you started with, because it all depends on what you started with. And you're trying to figure out like what percent would that be. So this fraction, like so 1,600 compared with 40,000 or 1,600 out of 40,000, what would this number have to be, you know, so that this out of 100 was the same? So this is finding the percent. It's finding what percent 1,600 is out of 40,000. And so again, I will leave the cross multiplying to you. Finish that up and then turn it in, okay?